Hello again. It's time for 3.4b Part 2. These are absolute value inequalities. So you have experienced absolute value equations in the past. Now we're going to apply what we've learned about that to inequalities. So an absolute value inequality is an inequality that contains an absolute value expression. For example, the absolute value of x is greater than 2, and the absolute value of x is, less than 2 and greater than 2. Those are absolute value inequalities because there's an absolute value symbol in the statement. It's as easy as that to identify it. So if we're saying that the absolute value of x is less than 2, that means that the distance between x and 0 is less than 2. There are actually two numbers that are 2 away from 0. So think about it this way. Here's 0. If the distance between x and 0 is supposed to be less than 2, that means that I could graph from here to here. From here to here, this would be not 2, but all the values less than 2. But isn't negative 2 also 2 away? And this section here would represent values that are also a distance of less than 2 away. So if you see a less than, it's actually going to end up looking like an and. So the graph of this would be x is greater than negative 2 and x is less than 2. Let's try the opposite of that. If this isn't making total sense yet, don't worry. We've got lots of examples. You can see this goes on for a couple pages. So the absolute value of x is greater than 2. That means the distance between x and 0 is greater than 2. Because remember, absolute value is just talking about how far a number is away from 0. So here's 0. If the distance between 0 and x is greater than 2, that means that it can't be 2, but it can be all the values greater than that. And negative 2 over here, that's also 2 away. So greater than 2 away could also be all the values in that direction. So if you see that the absolute value is greater than something, you're going to end up with an OR graph. You can tell this is an OR graph because there's a space in the middle with the ORs pointing out either way. So basically the pattern for all absolute value inequalities, if you see that an absolute value is less than, it's going to be an and. And the way I remember this, you know how I always have these weird ways of remembering things, and if you think of your own weird way, that's great. But the way I remember that less than is and is just by remembering the word land. So less than is and. If the absolute value is a greater than, so if whatever is isolated in the absolute value symbol on the left is greater than, it's going to end up being an or no matter what. And there's a few ways to remember this. The nice way is just to say great or. Instead of greater, you can say great or. So if it's greater than, it's going to be an or. You could also just remember the word gore. Greater than is an or. Whichever one you prefer. Or come up with your own if you don't like that. And honestly, when you go to graph this, if you forget, you're going to end up graphing it and seeing which one it is anyhow. It just makes it a little bit easier when you're doing the ands to know which direction it's going. So we're actually going to have to solve a few of these. And I have the steps listed out here. The first thing you need to do is isolate the absolute value term on one side of the equation, just like we did with absolute value equations. So you want the expression inside the absolute value symbols to be the only thing left. Then you're going to rewrite the equation as an and or an or compound. So rewriting it using less than equals and greater than equals or. So land gore. Then you need to solve both inequalities and graph your solution. So usually just having those words is not quite enough. Let's do some examples so this can be a little bit more real to us. Zoom in on this first one. So I have the absolute value of x plus 3 is less than 12. The first thing we need to do is get rid of this 3 here because it's not inside the symbol. So to get rid of adding 3 means we subtract 3 or add a negative 3, whichever. And you're left with the absolute value of x is less than 9. Okay, so first off, this is a less than, that means it's going to be an and. I'm just going to write the word and to remind myself. Okay, so if you recall, when we did our graphs up here, when I had that x is less than 2, it ended up being that, yes, x can be less than 2, but x could also be greater than negative 2. That's what's going to happen here. So in the past, when you had the absolute value of x equals 9, didn't that mean that x could be 9 or x could be negative 9? So with this, if we say that x, the absolute value of x is less than 9, that means yes, x can be less than 9, but x can also be greater than negative 9. So basically all we're doing is we're changing the direction of the sign and changing the sign of that number. So the first one, I just dropped the symbol. Yes, x is less than 9. Then we flip the sign. X can also be greater than negative 9. Because if we're saying that the distance between x and 0 is less than 9, from 0 to 9 will work, and from 0 to negative 9 will work, if you can kind of picture that. So when we go to graph this one, this is an and. I'm going to put negative 9 here, 9 here. X is less than 9. X is greater than negative 9. There's the both of the graphs together, so it would look like that. Okay, let's try another one. Now this is heavy stuff. I can't believe your book wanted to put both of these together. This is a lot of information. Okay, so we have our absolute value symbol. There's a 5 here that's not inside. It's not with the in crowd, poor little 5. So we're going to get rid of it by adding a negative 5. So x minus 8 in the absolute value symbols is greater than or equal to, when you take 11 plus negative 5, it is 6. Okay, so I have this absolute value symbol isolated, right? Now it's time to separate it into two equations. Is this an and or an or? The absolute value is greater, right, than the 6. So this is going to be an or statement. At this point, we're going to separate it into 2. So x minus 8, yes, it can be greater than or equal to 6. X minus 8 can also be, flip the sign, less than or equal to, and change the sign of that number, negative 6. And again, this is an or. So we need to solve both of these so that the variable is isolated by itself. So x can be greater than or equal to 14. When I add the 8 here, x can be less than or equal to 2. When you complete your graph for this, I'm going to put the lower digit on the left, so there's my 2. Higher digit on the right, there's 14. This hopefully will work out to be an or and look like ors. So if x is greater than or equal to 14, it can be 14. So I'm going to close that circle, and greater, yep, shade to the right. X is less than or equal to 2, that means it can be 2, or all the values less than 2. So yes, it looks like an or. That's good. All right, next page. Let's do a few more examples of this. I don't think 2 is enough for this stuff. It's pretty heavy. Okay, I need to get the absolute value symbol isolated. We're going to get rid of anything that's being added to the variable term first. We do that by adding a negative 1. I'm left with 4 times the absolute value of 2x minus 5, and that equals 28. I need that 4 to go away. These aren't parentheses. This is an absolute value symbol. I can't just distribute this 4 within the absolute value symbols because I only want the absolute value of this, not that. So 4 is being multiplied by that. So to undo multiplication, remember, we can divide. So to get rid of that 4, we divide both sides by it, and you end up with the absolute value of 2x minus 5 is greater than 28 divided by 4 is 7. Okay, at this point, you need to decide, is this an and or an or? It's greater, so that means this is going to be an or graph. So now we want to separate it into our two equations. So 2x minus 5, yes, that value can be greater than 7. Or 2x minus 5 can be less than negative 7. So I'm flipping the direction of the sign and changing the sign of the digit. Solve both of these. I'm going to add 5 to each side. 2x and 12. Divide by our 2. And we get x is, bring down the symbol, greater than 6. Or, I need to solve this one out. I get 2x here. I get negative 2 here. Divide by 2. And we have x less than -1. So there's our solution statement. We now need to graph that. So again, probably getting pretty good at graphing these. Lower digit on the left, higher digit on the right. It's an OR, so hopefully it'll look like an OR. It should. X is greater than 6. It means it can't be 6, but it can be all the values greater than that. X is less than -1. It can't be -1, but it can be all the values less than that. Yes, it looks like an OR. Thank goodness. I wouldn't want to do that all over again. All right. Last one of these, and then yes, we do have a few special cases. Okay, so I need to isolate the absolute value symbol. To do that, this 4.5 needs to go away. Remember, it's really a negative 4.5 because subtracting 4.5 is the same thing as adding a -1. So we're going to add 4.5 to each side. I'm left with the absolute value of x plus 3 on this side, and 7.5 plus 4.5 gives me 12. And my symbol is less than or equal to. At this point, I wanted to decide, is it an and or an or? We'll see that this is, the absolute value is less than, or land means this is going to be an and. So I'm going to separate it into our two statements now. X plus 3 can be less than or equal to 12, just like the original equation's written. And x plus 3 can also be greater than or equal to a -12. So we just switch the sign and change the sign of the digits. Let's solve these out. I'm going to add a -3 to each side, so x is less than or equal to 9. And I'm going to add a -3 over here. X is greater than or equal to -15. So there's my solution statement. Now we just need to graph it. Lower digit on the left, so I'm putting -15 over here. I'm going to put 9 over there. Yes, it matters. And if x is less than or equal to 9, that means it can be 9 or all the values less. And remember, this is an and, so I don't want to keep shading forever and ever because it's going to get cut off at the -15. X is greater than or equal to -15. That means it can be -15 or all the values greater than that. So the union of the two together, well, I guess where the two would overlap, would be between the 15s and the 9s. Closed circles on both because they both can be equal to either one. Okay, we'll do more practice with that. If it's still not rock solid, don't worry. Tomorrow in our starter, or unless it's Friday today, Monday on our starter, we'll do more practice and you'll get really, really good at these, I promise. Okay, so special cases, and we did have some special cases when we were solving absolute value equations. You need to take notice if the absolute value term is greater than or less than a negative term, because remember, absolute value expressions are always non-negative. When you measure distance, you don't measure it with negatives. I wouldn't say, I live -2 miles away from the school. You'd say, I live 2 miles away from the school. So if before you go to divide it into those two expressions, you see that you have an absolute value statement equal to a negative, there are two different things that could happen. If the inequality is true for the values of x, the solution would be all real numbers. If the inequality is false for the values of x, then there are no solutions. So let's put some examples with this so we can understand what all those words mean. So first off, you're not going to probably recognize these right away. We'll start solving this like we normally would. We draw our line, we get rid of that 7 by adding a -7, and we would see that the absolute value of x minus 6 is greater than -5. Now at this point, we should see that, oh, there's a negative value, and an absolute value of something can't be equal to a -5. But this is what I mean by, is this true? If we know that whatever value is in here is going to end up being positive, won't a positive amount always be greater than a negative? Yes. So it doesn't matter what value you put in here for x. After you take the absolute value of it, you're going to get a positive amount, which will always be greater than a -5. So that means I could put any number in here for x. That means my solution to this is all reals. I'm going to use my fancy little R here. So this statement is true. That means any number can make it true. And if you wanted to graph it, just look like this. All of them. So I just like the fancy R. All right, Let's try another one. I have x, the absolute value of x plus 12 minus 5 is less than or equal to negative 6. So you'd start off normal, normal, add your 5. You get the absolute value of x plus 12 is less than or equal to negative 1. Now with this one, again, you're going to notice, oh, the absolute value is supposed to be equal to a negative. That can't happen. Let's see if it's true. No matter what you do, after you solve this expression, you're going to get a positive value, right? Will a positive value ever be less than or equal to negative 1? No. A positive number will never be less than or equal to a negative number. So with this one, it doesn't matter what number I put in for x. There is not a number out there that will make this statement true, ever. So this is where I would say there are no solutions. All right, let's try a few more. If you want, you could pause me and try these last two yourself to see which one's which. You will get one of each, I'll tell you that. Or we can keep on going, whichever. So welcome back if you paused me. And hello again. So I already have the absolute value of 8x minus 11 isolated. I'm not going to try adding 11 to each side because my first task is to go ahead and get that isolated. So this one's a little bit different because I get 0 over here. I didn't get a negative number, but I have this will be less than 0. Remember that whatever happens here, I'm going to get a positive amount, right? Will a positive number ever be less than 0? No, only negative digits are less than 0. So when you look at this one, you can say, okay, there are no solutions. It's that easy. All right, take a look at the last one. I have the absolute value of x minus 9 is greater than or equal to negative 11. I need to get rid of this 9, so I'm going to add 9 to each side. So remember, subtracting 9 is the same as adding a negative 9. To cancel that out, I need to add it. So the absolute value of x is greater than or equal to negative 11 plus 9 is negative 2. So again, I'm left here with an absolute value statement and a negative number on this side. I know an absolute value can't be equal to a negative number. This is always going to be positive. But this means that either one can be true. So it doesn't have to be equal to negative 2. It can be greater than as well. Will a positive number always be greater than a negative 2? It sure will. So with this one, it doesn't matter what number I put in for x. After you take the absolute value of it, it's going to become a positive answer. And a positive will always be greater than a negative. So for this one, I would say all reals, because no matter what number I put in for x, they're all going to work. I'll see you tomorrow.